This is off tangent. This is way off subject. I don't know why I do these things. Let's go over here and look to the right. There's a lot of stuff on these drawings. Please move. And here you can see that actually these things, instead of being 12 inches, they're 3 inches. It's 3, 3, 6, 6, and then 12. Most builds will just double up and put them halfway between the other spaces. Like if you have a beam that's the width of the concrete is 8 inches, then your stirrups would be 8 or less apart. And you go to the end and you put one between in the 8-inch spaces and make it 4 and 4. You'd probably be better off to have a 2 3/4 and then a 3 3/8 or something, and then a 4-inch, and then and then jump it on out. Because the stresses are higher towards the ends, and closer to the end you get, the more stress you got. So they need to be progressive is a good term, I believe. Ours are progressive. Just because we had this plate with the holes in it, we slid down the bars and keep everything in line, and all we did was slap stirrups on it. So that went really quick. I think we tied 20 of them in 4 days or 4.5, less than 1 week, less than a work week. The problem was they were heavy. That's a lot of number 16 bars, and then the stirrups, there's a few number of pounds in that. It took a crew of 8 to pick these things up, carry them over, and stand them up in the hole. We didn't use any heavy equipment. We picked one of them up when we finished it from where we built it and moved it over near the site. And we knew we could pick them up from the first one we did. So we went ahead and made the rest of them. And because the jig was had stobs into the ground, we moved all of them away from the jig. We didn't move the jig, we moved the stuff we were putting together. And to put them in the ground, we had a stout piece of lumber called Goodwood, and we would carry them to where they would be overhanging that 6-foot hole, because it's only 6 feet deep and the hole was over 6 feet. So we'd hang it, and then when we tilted it up, about a third of the weight, if it's 6 feet and the column is 18, a third of your weight is trying to stand it up. So we only had to pick up 2/3 of it, and we didn't care if it slipped to one side or the other. We had a piece of concrete for it to land on down there. So we just sort of walked, you pick up one end and everybody starts walking forward, picking it up as you go. And we stood them up, I'd say about an hour a piece, because we took a break after we stand them up, and a couple guys would wedge some cocoa lumber to the ground and make them look like they're standing up. We didn't care if they were perfect, because we were going to pour a foot of concrete around them, and they'll stay in the hole if you do that. And then when we put the forms up, the forms are measured off the rebars at the bottom, and then they're tied for sure at the top, which is 8 feet up. And that many bars, 8 feet up, they're not going to bow out in the middle. If you had 1.5 inches of concrete around your bars at the bottom, it's going to look 1.5 inches all the way up. We do take and knock a nail into the top of the form and tire wire the about every other bar all the way around to exactly where we want it. Not that we climb on them while we're pouring, but things happen. So, other things that are normally under your house would be sanitation lines. Your 3 or 4 inch pipe goes from your CR and whatever size you're using for your gray water, like sinks and laundry equipment and stuff like that. And that's got a grade on it of 1 part in 48. That's 1/4 inch to the foot. That's a centimeter and 48 centimeters. The ratio is what it is. So we put all our wet stuff against the exterior wall. So when we put the tie beams around the base, like if we're going to run a 3-inch pipe, we put a piece of 4-inch pipe under the tie beam, never through it. Don't put it through it. If you have to put it through it, put it dead center. Don't put it near an edge, because you basically broke the beam in two when you do that. But we put ours underneath, and just routed out a hole underneath of it, and there's no, it's just laying in the bottom of this like trench. So when the concrete comes in, it fills the beam up and it covers over the top of your sleeve. But that lets us, a 4-inch lets you put a 3-inch pipe inside of it. So when we poured the tie beams, we didn't have the sanitary lines into the house. All we had was a place to put them. And then we could put them in when we were dealing just with 1 or 2 things like pipes. And we could get a level with a piece of wood taped under one end to give us the right grade. And they were only going in like 2 feet. So then we built, Boyette built some concrete boxes in the floor that went down deeper than the pipe sleeves. And that way we could do all our plumbing much later. I think it was a year, or maybe even the second year before we even looked at putting sanitary lines in. But they would be under the floor. And if you're going to run sanitary lines from halfway across the house, because your septic tank is one end, and if you went out the short way, you have to clear around the house. So you basically, wherever the thing is, you're aiming for the septic tank. If you can join a few together, that's good. But don't put a lot of joints under the floor. If you have to rod those things out or something, we have what's called a clean out Y. I just knocked the camera on. At least it didn't shut off. I think I'm just going to leave sleeping dogs lie. Some of it's on the screen. You have to watch where you put your clean outs, because you don't want them coming up in the middle of a room. There's ways you can hide them. You can have them come up, it's a 45 angle. You can bring them up through the bottom of a wall and to where they're flush with the surface of the wall. And you can cover them over with render and skim coat or something, or you could just have, if it's a basement, let them show. But we have a straight run from all our places where water comes in under the floor, so it goes out. And there's a clean out Y on every one of them that can come up into that concrete well. And because they're going to go under a sink, or they're going to go, you can put it behind the toilet, but you have a place to clean it out without taking fixtures down and cutting pipe apart. You can clean it out. So we had the straight runs put in a year later, and we cast some concrete caps on the top. The rebar's running across through the holes, so just throw a piece of plywood in there and a piece of polyethylene plastic and dump concrete in it. It's like they do lids on septic tanks. So we just flattened our floor up so nobody'd fall in it or hurt yourself. But that goes under your floor. And the critical thing is the grade, the 1 in 48. And not making any more length of line you have to have, because every 100 centimeters you go forward, every like meter long, you're 4.8 centimeters deeper in the ground. So the time you go around the house, it's 11 meters by 7 or something like that. You've added about double the length of your septic tank line. We ran electrical conduit. We got a piece of, in our case, we used 3-inch pipe because they redid our electrical drawing up to 175 amps, because that's the minimum, or that's the maximum that Meralco will run to a house without you paying for the transformer. So the town's electrical people, they changed it to that. We'd originally put 100. We're living where we stay. We got a 30 amp fuse. We've never blown the fuse, but we only got 1 refrigerator, no air conditioning, no hot water. And I guess they have standards. We ended up on the electrical drawing with 27 circuit breakers. And in actuality, we have 175 in the actual build, because the wire is expensive, and wire runs back to the circuit breaker panel. That's a lot of wire, and when you can buy an 8-breaker panel for 560 pesos, and then we can buy breakers in the U.S. and ship them. We can buy General Electric breakers here, but they're 220 volts, so it's a two-sided breaker. You know how they leave the cement out of hollow blocks and the glue out of plywood and the thickness out of steel and everything else? They leave something out, most expensive part. Well, the circuit that trips that breaker is only on one side. Their theory is that it goes in one side, it's got to come out the other. But that's not true. I'll argue with them on that. If the short is on the other side of the breaker, it's not protected. The breaker won't trip because the AC will work on one side, but it's the way the thing is designed. Oh, there we go. No picture, please. No, now we're going to select it and drag it all over the screen. Anyway, they have this common rail trip, and it'll stop the appliance from being on, but it won't stop back feeds and stuff. I just feel ill at ease using them when I can bring one with just a little different part number that I know will trip either one independently. It's almost like putting two single breakers in side by side and running 220 off of it. So I didn't like the way they were doing it. I don't know what country they're made in. I don't know whether the U.S. ones are made in U.S. Doesn't make any difference. Okay, so you have wiring under there. You have to have a water line coming in your house. You don't want to bring it over and put it through a wall where it's right out in the open. So that goes under the floor. Some people, they put a pipe in there for internet, television, all that kind of stuff. Think about putting a pipe under the floor. Putting it later is ugly. It just takes forever. The pipe is cheap. If you can think of a possible thing that goes through a pipe, or a separate location where you might want to actually have it a different place in the house. Once you come up through the floor, then you're trying to go through living space to hide the pipe. So if you think you might want to do something different, or really where you're putting the kitchen is going to turn into the family room and you're going to put the kitchen in a different place, you need to put pipes under your floor to handle the places that you might want to shift things to. So that goes under the floor. I don't care what you're pouring. If you're doing a poured floor, we use polyethylene. This buy it in rolls, 100 feet long, 20 feet wide. But you can go to the market, especially when they have the market days. A lot of provincial towns only have a big market one day a week, and then there's some stalls during the week. But you'll have somebody that comes down from the port, and when things come in like loads of lumber from Malaysia, units of lumber, and a lot of other things, they'll have a tarp because this stuff is stacked up on the deck of a ship out in the salt air, and this tarp is only used one time. It's a woven tarp covered in some kind of a plastic, and it's not real sunlight resistant over real long periods of time. But it won't be any sunlight under the floor, and they are dirt cheap. You can put those down under your concrete, especially if you put gravel or sand. Sand is every bit as bad as gravel as far as water going into it. But what you're trying to stop, other than losing your cement into the ground and making your floor weak, you're trying to stop radon gas. It's a radioactive gas. It's naturally occurring in clay soils on the entire planet. It's not like you have to be over top of a uranium mine. Radon gas comes up in the house, and it's a health hazard. Here we have no air conditioning mostly, or if you do, it's through the wall or a split unit, and you're only air conditioning in a couple rooms of the house a lot of the times. But if you have air circulation going through your house like we do, we don't have a possibility of radon because there's just a huge wind blows through this house. I'm going to do a video on that, I think. Not that I need more subjects. I got 1,000 I could do. Oh, talking about the videos. We're going to call this one number 7 because we lost number 7 in translation. If you're trying to make sense out of these videos, this video will probably be near the top if we get it to upload. And so you'll see this message if you watch it. I would watch them. They're called chapter this and chapter that because I was trying to upload them, was getting nowhere, and I thought it was a video, so I put names on them so I could make a chart to tell which ones I tried to upload and which ones I hadn't. So they all have names, whether they're in an order that makes any sense. Some of them are in order, like things doing with how you get your building permit. Anyway, if I can do it, I'll rearrange them. But if you watch them, the chapter numbers in order, it might be better, because it won't be referring to stuff that hasn't been shown, because it uploaded a month later. I think the problem is that the advertised internet speed on broadband, it's like the blocks with no cement and the plywood with no glue. They advertise a rate. That's only for the first few days of the month. And as you get closer to the end of the month, a 40 gigabit internet connection drops to 2 or 3. And then you're competing with everybody in town on the 2 or 3. That's why these videos are taking like 32 and a half hours to upload one video. So the upload is the kink right now. I found out that when the month changed to March, I had some that I've been trying to use, and I was testing, and I looked in 3 or 4 minutes, it was at 46%. I said, what in the world is that? I must have lost half of it when I uploaded it. And I looked in the number of megabytes in the video hadn't changed. So I turned it on and tried to play it. It was there. But that was the last couple I did, and that was the beginning of the month. So I'm going to try to stack up every one I've got and start putting them in there. You know, the dates on them will be the date that they were assembled here, and not so much the date they went up there. I don't know if that makes any sense or not. We are obviously new to YouTube. I've got a $3 brand new GoPro. Got them from China. And I got a phone. This is the phone. I know how to download the phone. I think I have to use my phone cable to download from the GoPro. The cable that comes with it is for charging only. Doesn't have a data stream wire in it. And they're wanting you to go wireless. It's cheaper for them to build. They just add software, you know, rather than give you a more expensive piece of wire. And for a $3 camera, hey, I can't blame them. But the case, the waterproof case, is identical to my Hero 3. And the camera is exactly the same physical dimensions. The buttons are the same place. Takes the same SD card. If you can get into this pretty cheap with a J4000 from China. They sell them on Walmart delivered for $4 and some cent. You know, no shipping. They come with the shipping. I got them, and they come in different colors on the faceplate rather than all black. The Hero 3's, the whole camera's black. But these ones here, I got a purple one and a blue one and a red one. They have to keep them separate for some reason. Okay. At the end of videos I watch, they say, if you gained anything from this video, you can give us a thumbs up. It's not necessary. It won't make any difference to whether we post another video or not. If you have something you don't like why would anybody put red rebar on the screen? Well, you can say, I don't like the color. Or could you make it a darker red? Yes, we could. Do you have to use black? I said, no, it's the default. And the default on the highlighted things is yellow. I can't change that part. Rambling when we present these things. I don't think there's anything to do with the 80-year-old guy trying to keep a train of thought. I can't tell you what I had for breakfast today, let alone keep something on subject. Maybe there's information in the rambling. Think of it that way. So if you want to give a thumbs down, that's perfectly fine. But like we say, we'd like to have a comment on what we're doing wrong, why you have a thumbs down. If you tuned this in and thought it was a video about fishing, well, you might be disappointed. You can put that down and say, this video is not about fishing. I saw the thumbnail and I thought it was about fishing. I said, well, whose mistake is that? I probably won't change anything. But at least I'll know why you did it. I watched some really nice videos by like Texas Filipino, and I look up there, and my PI Dream, James Tanner has a thing on Villa Feliz. It's detailed from one end to the other with videos. We're starting out with most of the structure of the house already poured in place and doing utilities and things. So we're using the CAD drawings to show you what's inside of the concrete rather than filming it, you know, which we could have done if we thought. I didn't know there was such thing as videos. We built this thing on our own wits. It's not wasn't anybody we could go to find out what we should be doing over here. I run it across that My PI Dream when I was looking for another channel I watched that had almost the same name. That thing was suggested. I said, hey, this is great stuff, you know. I watched the whole series. But we started before they did, so we had a year head start. Anyway, if you don't like them, say why. Oh, there's a good way to quit. The thing went off again. So y'all have a nice day. We have other videos. There's going to be some ahead of this one because I got a couple of them to actually upload. The introduction is uploaded. Of course, it's be in the middle of the pile of videos, but it will say introduction on it. It will also say chapter 1. And chapter 2 through 6, I think, is how you get your building permit. It's basically based on a set of drawings. They have to be blueprints. They can't be inkjet printed. They have to go through, make a celluloid, and you take the celluloid and burn blueprints. 8 sets of them. There's a lot of information in that. It's beat to death like this, what's under your house thing, but, you know, I don't think there's anything left out when we do one of these things. Well, you may have guessed this is a more technical-oriented channel than pointing your phone at the people building your house and trying to, you know, describe what you're pointing at. You know, what inside the frame of that picture is the thing that you're trying to point out. We do a little more depth on technical, and because I think it's information that's not really commonly available, and because some people are a little leery about being their own contractor, they'd rather pay the 1/3 more and hope that the guy finishes the house and doesn't get hit of the money. You pay them a contract price and they collect what's called draws along the way. You might be all in on your part of the money and the house isn't totally finished, and they say they'll come back or we'll get that later, and that doesn't happen. As a contractor, you said everything. You have to do. Yesterday we shopped the entire day. I needed I needed a T to put in the fuel line on the mixer because it decided it wasn't going to vent the fuel tank anymore. And you can't go out and buy a vented gas cap for an odd-built tank. So we decided to put a T in it and a vent at the filter. Anyway, we spent the day trying to find a T and bought some other stuff along the way. It's made, I don't know, 12, 14 stops, one of them for lunch. Anyway, we'll be back with another video, and you'll have a great day. Now, I'll see if I can stop it. Okay, it occurred to me that we've not looked at the other set of stirrups, so we're going to try to do that. There we go. Okay, this is the inside column, and these two outer panels stay the same, and this one that fit between them are switched, and that changes the shape of the column to an inside with exactly the same forms and bolts and everything. Again, we have one layer of stirrup in purple here, and we also have one here that looks like a Chrysler hood ornament, and that's different than the rectangular one that was in the outer ones. In fact, all these pieces are different. These three, none of them are the same as the other three. And it looks like this is an error here, but really it's doing what it's supposed to do. The stirrup is around the outside of the bar, but you can see that where we have here for that upright bar to pull that stirrup out, it's pretty well backed up with tied down here. Like all these, they got a bend right near the uprights. So, but this one here is on a long straight section, and it really sticks out when you look at it as being a weak point. But you got to realize that 99% of what's built, particularly in the Philippines, the entire stirrup is that way. They have the four corners, But then all the ones that are on the sides and on the bottoms, they're just along a straight section. And as soon as one rod starts to buckle and moves that, it's not touching the other two anymore. So that's why we do it the way we do it. Okay, now not on this drawing we have up now, or farther up on it, the outer column, there's something that's not in the drawings, but it's in the concrete. It has to be, really. There's a grid of 7 by 7 number 16 bars, just like a checkerboard in here. And the way this thing is put up and poured, we have a false bottom of concrete just to make all of them the same height and all of them just as level as we could finish them. On that, we throw down this grid, just toss it in the hole and kick it around a little bit till it looks like it might be lined up. No measuring involved. Then we tilt this thing up, this whole column arrangement, and these red bars come down and land on that concrete. Now we're going to scoot these red bars around till it looks like it's matching the strings. But at that point, we pick up that grid up against the bottom. This is a horizontal place on it. And that grid will be picked up and tie wired to the grid to the red bars. And of course, the grid goes clear across the center here. There's nothing to tie it to out there, but the grid's continuous. And that's goes near the bottom. So these bars are like 5 inches off the horizontal part. It's like 5 inches off the height of the support concrete. You know, it's a temporary piece just to make everything level. And the grid is tied to the bottom of these, and they're all number 16. So that gets you down to 4 inches plus off the bottom on a 14-inch thick slab of concrete. And the rest of the concrete goes up the bars here so that they're not reinforced right here to maximum stress point. They're up on the vertical part about 5 inches or whatever. Anyway, we don't have the grid drawn in here, and it's not drawn in the outer columns we already looked at. But it has to be in there. Any other glaring omissions? I've scaled this. I know what this is. I've scaled this drawing because I stole it off my building permit drawing. I've scaled it to where everything I wanted in the building permit fit on the piece of paper. It's got no relationship to the actual sizes. Normally with CAD, it's drawn full scale in CAD. The drawing itself is full scale. You print it, you change the inches in the drawing per inch of paper space or something to get it to fit on the paper. But this case, we had a border with all kinds of title blocks and signature places and different pieces that we wanted to put on that drawing, which were a different scale, but they're on this sheet in full size. But they were drug into this drawing just as a matter of convenience. And I opened it up, and I measured something a while ago, and it was really strange. And that's what it is. It's been rescaled in the drawing off of 1 inch equals 1 inch to fit on an output paper that we had like a prefabricated border, like a template, and we used that same template on all but the one with the 8 signatures. So that's what's screwed up here. I could erase that, but it's probably tied into 10 different things. Looks like it's available to get rid of. I think we can just push delete over here. That'll work. See, this is the one, well, it's the type we looked at. This is not the one we looked at. We looked at it up here in, well, there for one. Oh, I made the, colored these red bars so that, because it's kind of hard to follow anything when it's all the same color. But we wanted a black and white print for the building permit because it had to be a blueprint. They don't accept inkjet, which lets you have colors. You have colored laser jets. They don't accept that either. They only accepted blueprints. Now I don't know if that's Philippine wide, or it's maybe it's only our town. I don't know. But anyway, we were kind of disappointed, and we had all these detailed drawings and thought we couldn't use them. But went to the CAD place with the file. And they said, no, that's not a problem. We can make them all black and white, and we can make a celluloid off your CAD file, and then that will be the same thing as if you drew it on tracing paper. Now, I'm not a fan of tracing paper. Oh, this is the diameter of the what she's calling dining room, and this is 28 feet, I think, between these walls. So obviously these rooms that are bedrooms and kitchens and stuff are a fairly good sized room. Yeah, there it is in meters. Okay, I'm going to attach this like a supplement to the video that we looked at a second ago. Somehow the camera separated it into two separate files, and I'm not familiar with editing, but I know if I put both of this supplement and the other file in the same window and ask it to save it, it's going to run them all together into one continuous file. So I expect this is going to be stuck on the end of the first file. If that file's too big, we'll stick it on the front of the other file. Whatever order they are in that window, when you're saving it, that's the order that puts them together. You find these things out as you screw things up. I ruined my original introduction and the first building permit video because I didn't know how the software worked. And time I was done, I couldn't unglue them. There's no such thing as a backup and redo on that software. It's you know, you screw up, it's just like pushing a race. You can't get it back. Structural concrete, 300 psi minimum. This is for so that there's no way we could not pass the test of our concrete. We mixed the concrete at 8,000 psi and didn't put in any extra water, and we didn't absolutely have to have. But there's not any way to fail my building permit drawing on concrete strength, because the drawing lays this out and they've already signed it. If they can't read, well, that's a problem too. Okay, so we're going to shut this off and try to attach this thing. I just thought I know somebody was going to, well, maybe I don't know anybody's going to do it, because somebody would actually have to find this video and watch it and care enough to comment that I needed a grid in the bottom of these holes. That's getting out there pretty far, because I'm not sure anybody will ever find any of these things. I just wanted to provide some technical insight into building in the Philippines, things that it took us a couple years to figure out and learn. And if nobody can read it or can use it, well, I haven't lost anything. I think the world might be worse off for it. Okay, we're going to attempt to shut this off.